This is a video on multiplying polynomials. So when we multiply polynomials, the first thing you should recall from previous sections is that when you multiply two things with the same base, so if I have x to the m times x to the n, they're both base x. When you multiply things with the same base, you add their exponents, so it's equal to x stays the base, and then m plus n becomes the exponent. So when you multiply two things with the same base, you add their exponents. That's going to help us go through some examples here. The first thing to talk about is multiplying, just a monomial by a monomial. So the directions here might say multiply or perform the indicated operation. For this first one, if I said I had 4x squared times, in parentheses, 7x to the 15th power. First off, monomial times a monomial means one term times one term. So when I multiply these together, what you really do is you multiply the coefficients. So 4 times 7, which gives us 28. And then multiply the variables. X squared times x to the 15th. Remember, when you multiply things with the same base, the base stays the same, and you add their exponents. 2 plus 15 makes this x to the 17th. So we get 28 x to the 17th. A similar one, if I wrote something like 5x to the 3rd y to the 9th times, in parentheses, negative 8 x to the 2nd power y to the 5th. Again, it's a monomial times a monomial. When you multiply these together, keep in mind that this is still one term times one term. It's not distributing. You're really multiplying the coefficients with the coefficients, the same basis with the same bases. So when I multiply this, 5 times negative 8 gives me negative 40. X to the 3rd times x to the 2nd. Remember, the base stays x. When you multiply, you add the exponents, so 3 plus 2 makes this x to the 5. And then y to the 9th times y to the 5th. The base stays y. Remember, when you multiply, you add the exponents. 9 plus 5 is y to the 14th. So this would be negative 40x to the 5th, y to the 14th. In a similar way, you might see monomials times polynomials. If I had 10x squared times, and then in parentheses, 3x to the 5th plus 4x squared minus 8. This is a monomial times, really a trinomial. It has three terms, but this is a polynomial here. So when I multiply this 10x squared has to be multiplied to each term individually. In other words, it has to be distributed. 10x squared times 3x to the 5th would give us 10 times 3 is 30. X squared times x to the 5th is x to the 7th. So we did really exactly what we did above in these examples here, but now we're going to do it term by term. So the first term, 10 times 3 gave me 30. X squared times x to the 5th, 2 plus 5 gives me x to the 7th. And then we distribute in. We had a positive 10 times a positive 4, so we know it's going to be a positive 40. X squared times x squared is x to the 2 plus 2 gives us 4. Make sure you know you're adding those to get x to the 4th power. And then distributing 10x squared to the negative 8. 10 times negative 8 is negative 80. The x squared doesn't have any x to be multiplied by. It's really being multiplied by 1, so it's just coming along as x squared. So we got 30x to the 7th plus 40x to the 4th minus 80x squared. Don't lose that x squared on that last term. It still comes along, but only the coefficients are going to get multiplied. And we'll look at just one more like that. If I said I had 3x squared y, I'm multiplying to 2xy plus 7x y to the 4th minus 5. Again, it's a monomial times a polynomial. You're going to distribute through. When you multiply through, 3 times 2 will give me 6. X squared times x gives me x to the 3rd. Y times y gives me y to the 2nd. Now, if you're not sure how I'm getting these powers, right? This is a power of 2. This x really is a power of 1. So 2 plus 1 gives me 3. Y is to the first power. Y is to the first power. 1 plus 1 gives me y to the 2. So that's the first term. Distributing through, positive 3 times a positive 7 gives us a positive 21. X squared times x to the 1 makes this x to the third power, remember, because 2 plus 1 gives you the 3. And then y times y to the fourth makes this y to the fifth, because 1 plus 4 gives you 5. And then distributing to the last term, 3x squared y times a negative 5. The 3 times negative 5 makes that negative 15. The x squared and y don't have any similar bases to be multiplied by, so they'll just say x squared y right after it. And that gives us our answer. Next we'll talk about multiplying a binomial by a binomial. When I say that a binomial is something that has two terms, so I'm really saying multiply something that has two terms. Let's call this one a plus b times something else that has two terms, which I'll call it c plus d. And basically what you want to do is distribute through each term from the first to each term in the second. And we have a systematic way of doing this. Call it FOIL, it's an acronym. Alright, so F-O-I-L. The F stands for the first, so I'm going to multiply the first together. So A times C, that's my first step in FOIL. I get AC. The O stands for the outer, so I'm doing this A times D, so it'll be plus AD. The I stands for the inner, so these inside ones get multiplied together, so it'll be plus BC. And the L stands for last, meaning multiplying the last term of each. B times D makes this plus BD. And, you know, when we talk about foiling, we're really talking about multiplying a binomial by a binomial. You'll hear people say to FOIL for short. But remember, it's an acronym giving you a systematic way to multiply through. Let's take a look at some examples. So again, the directions might say multiply, it might say perform the indicated operation. You know it's multiplication because they're written in parentheses next to each other. For this first one, if I said 4x minus 3 times in parentheses x plus 2, we're going to have a binomial times a binomial, so that tells us we're going to FOIL. Remember, be systematic. So this is our first. So 4x times x, remember how we multiplied before, right? 4 times, really there's a 1 in front of it, just stays 4. X times x, remember, is x to the second power. Don't lose that, right? It's 1 plus 1 gives you a 2. Don't lose that squared. A lot of people make that mistake. Alright, so that was the first. The outer, the 4x times a positive 2 makes us a positive 8x. The inner, we have negative 3 times x. Make sure you take that sign with it. It becomes negative 3x, right? That's for my inner. And then my last, the negative 3 times a positive 2. Again, make sure you're multiplying the signs. Negative 3 times 2 makes us a negative 6. Now, once you're here, you want to simplify this as much as possible. In other words, combine like terms. Now, there won't always be like terms, but a lot of the times there will be. So here we have 4x squared. That'll stay. The 8x and the negative 3x are like terms. Remember, they're the same variable with the same exponents. So positive 8x minus 3x gives us a positive 5x and then minus 6. Now let's take a look at another one here. If I said I had 2x plus 7 times negative 3x minus 2. Again, we have a binomial times a binomial. That tells us that we're going to FOIL. So multiplying the first together, We had 2x times negative 3x, so 2 times negative 3 is negative 6. X times x gives you x squared, remember, because 1 plus 1 gives you 2. The outer, 2x times negative 2 is negative 4x. The inner, it's a positive times a negative, which makes it a negative 21x, right? Positive 7 times negative 3 gives you negative 21. The x comes along. And 7 times negative 2 is negative 14. Again, we combine like terms if we can. In this case, we do have like terms in the middle. So we have negative 6x squared minus 25x minus 14. None of those are like terms. They can't combine any further. Take a look at a few more. If I was to write this one here, we have 8 minus 3x times 7 minus 5x. Again, we have a binomial times a binomial, so we FOIL. 8 times 7 for my first gives me 56. My outer, 8 times negative 5x, a positive times negative makes it negative 40x. My inner, we had a negative 3x times a positive 7, so it'll be a negative 21x. And then my last, I've got negative times a negative, which makes this a positive. 3 times 5 is 15. X times x is x squared. And again, we want to combine like terms if we can. Noticing the middle there are like terms. 56 minus 40x minus 21x is minus 61x plus 15x squared. And you could leave it like that. More typically though, you're going to see this final answer written in descending order. Descending order, remember, means that you want the highest power of the variable first. And you want to write them in sequential order of powers going down to 0 power. So it's a positive 15x squared, so you start with a positive 15x squared. Make sure you keep that positive. Then negative 61x, so you keep a negative 61x. It's a positive 56, so you put plus 56. These are the same answer, they're equivalent. It's just a matter of the second one's written in descending order. Some special cases here. If I wrote x minus 9, the quantity squared, keep in mind that what squared really means, right, to the second power really means is multiply that same thing times itself. So it means write it twice. It means write x minus 9 times x minus 9. What you can't do is you can't bring the power of 2 to each term inside of there. Sometimes people get this confused with our exponent rule if we had multiplication or division on the inside. If we have multiplication or division on the inside, you could bring it through. But because this is more than one term being added or subtracted, you can't bring that power of 2 to each piece. So you have to write it twice. Once you write it twice, now we follow through with FOIL, right? It's a binomial times a binomial. So x times x gives us x squared. X times negative 9 makes us negative 9x. Negative 9 times x is negative 9x, so minus 9x. And a negative 9 times a negative 9 makes us a positive, watch your sign there, 81. And again, once you're here, you're going to combine like terms. Negative 9x minus 9x, be very careful, they don't cancel out. Negative 9 minus 9 makes it more negative. Remember, when you're subtracting from a negative, you really add the absolute value of the numbers and then make it the sign you have. So negative 9 minus 9 makes us negative 18x plus 81. And then you got it. So be sure to write this twice. You cannot make this 2 go to each piece, because sometimes you'll write x squared minus 81, and that'd be incorrect. You can't bring that power of 2 in. You have to write it twice and then multiply through by using FOIL. So one's similar but different. If I wrote this, x plus 9 times x minus 9. Alright, so it's already in the form we need a binomial times a binomial. We're going to FOIL this. So x times x gives us x squared. X times negative 9 is negative 9x. Positive 9 times x is plus 9x. And a positive 9 times negative 9, it's a negative 81. Now for this example, combining like terms in the middle, a negative 9x plus 9x, that's really giving you 0x, right? Negative 9 plus 9 is 0. X comes along when you combine like terms, which really means they just cancel out. Right, so negative 9x plus 9x is just 0, so you end up with x squared minus 81. Don't confuse what we did down here with the example above. The example above, they didn't cancel because these signs were the same. This example here, the signs are opposite. That's what allows them to cancel when you combine like terms. So be very careful of that. Usually people get these two types of things confused. If it's something that's being squared, you write it twice, FOIL through. If something just being multiplied by what we're going to call its conjugate eventually, it's a little bit of a term we're going to use later on, those middle terms will cancel out. If you know they're going to cancel, you don't necessarily have to show it, but I would recommend showing it so you don't make an error between the two cases. And we'll look at one more that's a binomial times a binomial. If I wrote this as 2x minus 3y times 4x plus 6. Again, binomial times a binomial, we want to FOIL this. 2x times 4x gives us 2 times 4 is 8. X times x is x squared. 2x times positive 6 will give us a positive 12x. Negative 3y times 4x. So negative 3 times 4 is a negative 12. Here we got x and y, but they're not, they don't have the same base in the other term you're multiplying to. So you just keep them both. Typically we'll write it in alphabetical order, so I'll write xy. If you wrote yx, it wouldn't be incorrect, but more often than not, you'll see it written in alphabetical order. So the y stays, the x stays, there's nothing to multiply them to with the same base. You just keep them both there. And then negative 3y times a positive 6 is going to be a negative 18. Don't forget the y comes along. Now, most of these cases we had previously, the middle terms were like terms. In this case, they're not. They have different variables, so you can't combine them. So there are no like terms, so you just leave it alone. And we'll just look at a few more examples here. So now we'll multiply some other polynomials. So if I said to multiply for this first one, 3x minus 1 times 2x squared plus 4x minus 7. Now your first instinct might be to say FOIL, but FOIL, remember, only is for a binomial times a binomial. But the same idea of FOIL applies here. In other words, you want every term of the first polynomial to be multiplied to every term of the second polynomial. I would recommend being systematic with this, so I would bring the 3x through first, and then bring the negative 1 through second. So 3x times 2x squared, 3 times 2 gives me 6, x times x squared gives me x to the third power. 3x times a positive 4x, 3 times 4 will give me a positive 12. X times x gives me an x squared, don't lose that. 3x times a negative 7, and positive times negative makes this a negative 21. X comes along, don't forget the x. And then, because I'm trying to be systematic, now I'm going to take the negative 1 and multiply it to all the terms of the second one. So negative 1 times 2x squared is going to be a negative 2x squared. Now I'm going to write this right underneath the same like term. You don't have to, but it might help you organize things later. If you wrote it as a straight line straight across here, you'd still combine like terms like you normally would. And then we do negative 1 times a positive 4x. Make sure you bring the negative with it. Negative times a positive makes this a negative 1 times 4x is just minus 4x. And negative 1 times negative 7 makes us a positive 7. So then once you're here, you know, to combine like terms, I've organized them in a way where the like terms are already lined up. If you had written in a straight line, you still combine like terms like you normally would. So in descending order, we have 6x to the third. Positive 12x minus 2x is still positive 10x squared, right? So 12x squared minus 2x squared is a positive 10x squared. Negative 21x minus 4x is negative 25x. And then positive 7 just stays positive 7. None of these are like terms, so you just keep it as is. Alright, take a look at another one like this. If I said I had 3x squared plus 4x minus 1, I'm going to multiply that to 8x to the fourth minus 5x squared plus 6. So now we got a trinomial times a trinomial, right? 3 terms times 3 terms. Last one's a binomial times a trinomial. But you're still doing the same type of thing. You want to make sure every term of the first polynomial is multiplied to every term in the second. So be systematic. You know, it's helpful to be systematic about it. So when I multiply these together here, I've got 3x squared times 8x to the fourth. 3 times 8 is 24. X squared times x to the fourth is x to the 2 plus 4, so it's x to the sixth. 3x squared times a negative 5x squared is going to give me negative 15x to the 2 plus 2, makes it x to the fourth. 3x squared times a positive 6 makes this a positive 18x squared. And now I'll look at multiplying the 4x through each piece. So 4x times 8x to the fourth, well, that'll be a positive, and this one doesn't really combine, so 32x to the fifth. In other words, when I say it doesn't combine, it doesn't have a like term already here, so I'm just going to write it at the end. Positive 4x times negative 5x squared will be a negative 20x to the third. And then a positive 4x times positive 6 makes this positive 24x. And then the last term, the negative 1 is going to get brought through. So we have negative 1 times 8x to the fourth will give me a negative 8x to the fourth. I'll write it under its like term. Negative 1 times a negative 5x squared makes that a positive 5x squared. Again, I'm writing it under its like term. You could still continue writing it in a line if you wanted to. And negative 1 times a positive 6 makes us a negative 6, which really doesn't have a like term. So when I go to write the answer, really, I'm just adding up the like terms, writing it in descending order. So the highest power I see is 6, so I'm going to write that term first, 24x to the sixth. The next highest power is x to the fifth, so I'll put the plus 32, make sure you keep the sign with it. X to the fifth. The next highest power I have is x to the fourth, and I got two of those to combine. Negative 15x to the fourth minus 8x to the fourth is negative 23x to the fourth. Next I have a negative 20x cubed, make sure you have the negative with it. Then we have x to the second power. We got two of those terms to combine, so 18x squared plus 5x squared is plus 23x squared. And then our x term, we just have plus 24x. And then minus 6. None of these are like terms. I know it seems tedious. I mean, you really had to do, 9 multiplications there. But you still can get to the same answer. It's still the same process. You're multiplying through from each term of the first to each term in the second. And I just want to do one example that kind of combines things that you may have seen before into one problem. So if I just wrote perform the indicated operation. The first thing we'll do is take a look at something like this. If I said I had x squared plus 3x minus 4 in parentheses, and there's a minus sign here, and then in parentheses 3x squared plus 5x minus 8. When you look at this, it's important to understand what the indicated operation is. The operation is subtraction. It's not multiplication like we did above. When it was multiplication, they were written right next to each other without something in between. That's why you knew it was multiplied. Parentheses next to each other means multiply. Here, there is something in between, a negative sign, which means you're actually subtracting. This is not multiplying at all. For this first part, remember, you drop the parentheses and you just have x squared plus 3x minus 4. Here, this is really like a negative 1 in front you want to distribute through. So with negative 1 times 3x squared is negative 3x squared. Negative 1 times positive 5x is negative 5x. And negative 1 times negative 8 is positive 8. Once you're here, you combine like terms. Combining the like terms, you have x squared minus 3x squared gives you negative 2x squared. Positive 3x minus 5x is negative 2x. Negative 4 plus 8 gives us a positive 4. So this example wasn't multiplying at all. This was actually a subtraction problem. You subtract a polynomial here. Remember, you have to distribute the negative 1 through to each piece. You should have seen this before. I'm just trying to show you the difference between what we did today here, multiplying, and what you would have done here when you have subtraction. So that sign in the middle makes a difference. The next one, if I wrote this 3 and then in parentheses x minus 7 squared minus in parentheses after it x squared plus 4. Really, I mean, for this one I should say perform the indicated operations, right, to simplify this part. First off, keep an eye on what we have here. You cannot distribute this 3 into here, and the reason you can't is because there's an exponent on the outside. If there wasn't an exponent here, you would distribute the 3 in. But because you have this exponent of 2 out here, you have to actually take care of the exponent first. It's kind of like when you had order of operations. So if I want to take care of this exponent first, I have x minus 7, the quantity squared. That really means to multiply x minus 7 times itself, remember. So this is going to be 3, and then parentheses x minus 7 times x minus 7. All right, and then minus, I'll just keep this as it is for now, x squared plus 4. Make sure you have that minus sign, right? Because that's subtraction is what it really means. Now, once you've written this, we're going to go through each term and simplify. Here, I'd keep the 3 in front, and I'd simplify this binomial times binomial by FOIL. So 3 times whatever's after it, so make sure you have parentheses, because you still have to multiply the 3 to it. You have x times x, which gives you x squared. X times negative 7 makes this negative 7. X. Negative 7 times x is negative 7. X. And negative 7 times negative 7 is positive 49. So that's all the first term, right? That's down there. Minus. Now when I have minus here, that's really like a negative 1, remember, in front you're distributing through. We just saw it in the last example. So negative 1 times x squared is a negative x squared. Negative 1 times a positive 4 is a negative 4. You can drop those parentheses after you distribute the negative in. There's nothing else to multiply there. In the next step here, to simplify this, I want to combine your like terms. So we have 3 times x squared. Remember, negative 7x minus 7x. They don't cancel, right? It becomes more negative if they have the same sign. So negative 7 minus 7 is negative 14. Bring the x along when you combine like terms, plus 49. We still have minus x squared minus 4. And then remember, to simplify this, now I want to get rid of these parentheses here because I can distribute the 3 in. You have to distribute the 3 in before you can combine any of these like terms with what's here. So Now we'll multiply the 3 through. So 3 times x squared is 3x squared. 3 times negative 14x is negative 42x. And 3 times a positive 49 is plus 147. And we have minus x squared minus 4 here at the end. And now we'll combine like terms. 3x squared minus x squared is 2x squared. Negative 42x will just stay negative 42x. And positive 147 minus 4 is positive 143. None of this is like terms, so you leave it. So this is kind of bringing together things that we learned about adding and subtracting polynomials along with things we learned about multiplying them.